All right, let's peel back the skin on a huge crisis that's threatening a fruit pretty much all of us love. We are talking about the banana and a silent killer that's on a mission to wipe it right off our grocery store shelves. And it all kicks off with one pretty surprising number. To really get the scale of this problem, you have to know this number, 40%. That's right, 40% of all bananas grown and eaten all around the world are just a single variety, the Cavendish. And here's the kicker. They're all sterile clones, which means they're genetically identical, every single one. That uniformity is their biggest strength, and, as it turns out, their greatest weakness. So just imagine for a second, what if that one dominant variety just vanished? I mean, for millions of people, it's a crucial food source. For the global economy, it's a massive, multi-billion-dollar industry. The stakes here, they honestly couldn't be any higher. Now, the threat comes from something that's been quietly spreading across the planet for decades. And this isn't some bug or a blight you can just spray away. Nope, it's a fungus, and it is a relentless, devastating killer. It's called Fusarium wilt, but more specifically, we're talking about a strain known as tropical race 4, or just TR4 for short. It's a fungus that lives in the soil, and it's absolutely lethal to Cavendish banana plants. And once it's in the soil, it can just sit there, waiting for decades. So how exactly does it work? Well, TR4 is incredibly sneaky. It gets into the plant through the roots and then works its way up into the vascular system. You know, the xylem, which is basically the plant's plumbing. It's how it gets water and nutrients. The fungus then just clogs those vessels up, completely starving and dehydrating the plant from the inside out. Now, what you see on the outside, it's just devastating. The older leaves at the bottom start to turn yellow, right from the edges inward. But as they die, they don't just fall off. Instead, they droop and hang down, creating this really grim skirt of dead leaves around the plant's base, all while the fungus just keeps marching upward to the younger leaves. And this right here is the absolute crucial point. There's no chemical treatment for it, no fungicide that can cure a plant or clean the soil. Once a plantation has TR4, that land can't be used to grow Cavendish bananas anymore. It is a death sentence for the farm, period. But you know, this story isn't all doom and gloom. It actually has some heroes. Faced with this enemy that seemed totally unbeatable, scientists didn't look for an answer in a chemical lab. They actually looked to nature itself. They knew they had to find some way to give the banana a fighting chance. And this is where the story gets really fascinating. The key to survival wasn't some new chemical spray. It was found in a wild banana relative. Now, this wild version, you wouldn't want to eat it, but it had something that our beloved Cavendish had lost over time, a natural built-in genetic resistance to that nasty Fusarium fungus.
Now, this actually wasn't the first try. An earlier variety called Formosana was developed, and it was tolerant to TR4. That means it could survive an infection, but it wasn't really immune. It was a good first step, for sure. But the real game changer is a much more advanced solution called QCAV4.
So what is QCAV4? It's a Cavendish banana that's been genetically modified. Scientists at Queensland University of Technology figured out the exact gene from that wild banana that gave it resistance, a gene called MAMRGA2, and they successfully put it into the Cavendish genome. This basically gives the plant the power to spot and fight off the TR4 fungus all by itself.
And hey, this isn't just a theory in a lab. It's been proven in the real world. The front line for this scientific breakthrough has been Australia, a country whose banana industry was facing a huge, imminent threat from TR4.
And if you look at this timeline, you can see this was no overnight fix. We're talking years of development, and then more than 7 years of really tough field trials in Australia's Northern Territory. I mean, they deliberately planted these bananas in soil they knew was infested with TR4 just to prove their resistance before finally getting that all-important government approval. And the result of all that work? Well, in early 2024, Australian regulators gave it the big green light. QCAV4 was officially declared safe for both commercial farming and for all of us to eat. This is a massive win, a huge proof of concept for the entire world.
That brings us to part 4, the cure versus the concern. This is where we get into the huge, messy, global debate about GMOs.
For supporters, it really boils down to a few key points. First, and this is the big one, it is the only practical solution to a disease that has no cure. It's not like there are other great options on the table. Second, this is about protecting a massive global food supply that millions rely on. And third, this isn't some rushed-out experiment. The QCAB4 has already passed years of extensive safety assessments by major regulatory agencies. And this quote, this really gets to the heart of the whole pro-GMO argument. It's a risk calculation, right? The very real, very immediate risk of losing a major food crop is seen as a much bigger danger than the potential or speculative risks that might come with the new technology. This is where it all gets messy. Because what seems like a perfect fix in a laboratory is sparking a ton of opposition out in the real world, raising some really fundamental questions about the food we grow and the future of farming. So first up, you have the ecological worries. Critics are asking, what actually happens when we start planting millions of these things? Is it possible that the engineered gene could spread to wild banana relatives? What are the long-term knock-on effects for the local ecosystem that we just can't predict right now? These are the big, scary unknowns. Then, of course, there's the health angle, and this is a tricky one. Even though regulators have given it a stamp of approval, that cloud of public skepticism is still there. The concern isn't about any specific proven harm. It's about the lack of long-term data. What happens after people eat these for 20, 30, 40 years? We just don't know, and that uncertainty makes a lot of people very nervous. And finally, this isn't just about science. It's also about money and power. Who owns the patent on this technology? There are huge fears that a patented banana could make small farmers completely dependent on a handful of large corporations. It could disrupt traditional farming practices. And for some, it's just a matter of principle, a fundamental distrust of meddling with the very code of life in our food.
So, on one side, the argument for this new banana is pretty straightforward. We've got an incurable disease that's threatening a critical food source. This new banana works, and regulators have tested it for years and say it's completely safe to eat. It looks like a no-brainer, right? Well, on the other side, you've got some serious concerns. People worry about unintended side effects on the environment. There's also a general distrust of GMOs and their long-term health effects. And then there are the economic worries, like will farmers become dependent on one patented product? But maybe the biggest hurdle of all is us, the public. Will people actually be willing to buy a banana they know is genetically modified?
And that whole debate leads us straight into our final section, the banana of tomorrow. Because this isn't just a science experiment anymore. QCAV4 is real, and it's starting its long journey from the lab to, hopefully, the grocery store.
And that leads us to the big question, right? We have a banana that can survive this plague, so why isn't it being planted everywhere to save the industry? Well, it turns out the hurdles that are left aren't scientific anymore. They're social and they're political.
The path forward really involves a few key steps. First, public education is absolutely vital to tackle the fears and just the general uncertainty around genetic modification. Then, you've got the economic incentives needed for farmers to actually make the switch. And finally, there's the incredibly complex web of different regulations in countries all around the globe.
And this really gets to the most important message in that whole education effort. This isn't about creating some weird artificial frankenfruit. The solution, the gene, was borrowed from the banana's own family tree. It's a natural defense, just given back to a variety that lost it over generations and generations of cultivation.
You know, the story of the Cavendish banana is a really powerful lesson for the future of our food. It shows us how relying so heavily on just one genetic variety can leave us incredibly vulnerable. And it leaves us with a pretty critical question to think about. As we face new diseases and a changing climate, what other foods that we all rely on are going to need the same kind of innovation just to survive?